Alright, so our presentation is on air pollutants. Of course, we've gone over a lot of things, a lot of pollutants that can lead to harmful environmental changes such as global warming and acid rain. But our presentation is going to focus on 4 major pollutants that have a direct harmful effect on humans. And we're going to be focusing on carbon monoxide, sulfur dioxide, toxic organics, and particulate matter. Alright, carbon monoxide, the first one, CO. It's a colorless gas. It occurs naturally in the environment and inside of our bodies, but in too high doses it can be asphyxiating. Because once it gets inside the body, it binds with hemoglobin in the blood, which prevents the hemoglobin from transferring oxygen. And here's a little diagram of what it does to the hemoglobin. On the left, you see normal hemoglobin carrying oxygen and carbon dioxide. On the right, you see the carbon monoxide binding tightly, and thus the oxygen and CO2 can no longer be carried. Go back to the last one. The main causes of carbon monoxide emissions are from transportation, but it's produced whenever combustion is incomplete, and another source of it is malfunctioning stoves and space heaters in homes. The health problems involved with CO. Inside the body, it's 1% of hemoglobin sites in the human blood, and it doubles in smokers. But in higher concentrations, that percentage can go up. And the severity of the harm depends on the concentration in the air. Obviously worse in areas of heavy traffic and closed spaces. And it also depends on duration of exposure and level of exertion. If you're exercising, it'll be worse while you're exposed to the CO. And I found this stat that each year in America, carbon monoxide poisoning claims approximately 480 lives. Here's a little chart of the various levels of CO and their concentrations and the effects they have on humans. Basically, you can see the lower levels you can be exposed to, and as you get higher, like 800 and 1600, you get headache, dizziness, nausea, and collapse and death in an hour or two. And obviously up near the top, you really don't want to be there because you'll die. For some reason that chart's not coming up. So emissions of CO peaked around 1970 when there was a lot of transportation and not that many laws regulating it. This chart is supposed to show Philadelphia's concentration of CO from 1990 to 2006, and it declined pretty much steadily, even though there was a sharp increase in 1993.
Okay. The next 3 are summarized on this chart. Just gives the basic structure and then some of the basic facts about it. The most important thing about sulfur dioxide, formaldehyde, and acetaldehydes, benzene, and pH. So first is sulfur dioxide. We've talked about in class before. SO2, obviously, and it also can be even more dangerous when combined with oxygen or water and create sulfuric acid aerosols. So the causes are industrial emissions, smelting of metals, including copper, iron, and nickel. But the biggest cause, 63%, and some sources say up to 74%, are caused by the combustion of coal for electrical power. The health problems at above 0.25 parts per million, you start to aggravate cardiovascular diseases that are already present, especially asthma. It can induce asthma attacks. And in any person above, when the concentration reaches above 6 parts per million, you can get wheezing, tightness in the chest, and shortness of breath. At the very highest concentrations, you can get severe symptoms, which are burning sensation in the nose and throat, difficulty breathing, and severe airway obstruction, which is more than 100 parts per million. One very extreme case, Chongqing, China, a city in China, and in 1995, 9.6 people per day died on average. I guess they can attribute it almost exclusively to sulfur dioxide. In addition, in general, sulfur dioxide weakens the respiratory system's defenses against other foreign particles and bacteria, and And obviously in places where you have sulfur dioxide, you also have a lot of particulate matter and a lot of the other pollutants that we're going to talk about. So all the effects of those other ones will be exacerbated by the presence of sulfur dioxide. Sulfuric acid is even more dangerous, as I said before. It causes irritation of the small blood vessels in the lungs, which swell and block passages that are necessary for breathing. Here is environmental problems. Obviously, this is a sort of peripheral problem. It doesn't involve a direct effect to humans, and it's touched upon by some of the other groups that have talked today. They talked about acid rain and so forth. But sulfur dioxide accelerates the corrosion of iron. That's the basic formula there, and dissolves limestone. However, when sulfur dioxide is involved in these two natural processes, it speeds it up and obviously makes the problem worse. So the corrosion of iron and limestone obviously affect outdoor monuments, any structure that's created with exposed steel or iron. And so obviously there's also an economic effect. Buildings that are made with iron and steel parts exposed periodically must be coated with expensive protective paint. In addition, plants can sustain visible damage at as little as 0.12 parts per million. Most sensitive plants can sustain damage and at 0.3 parts per million. Many other plants also have those. And as I said, some peripheral effects are acid rain, which have huge effects, as we saw. The source that I had for data that I used to plot this, unfortunately, only had 3 years. But it shows sulfur dioxide emissions, and even from just the 3 years, you can see some trends. First of all, the biggest thing is that the larger, more developed countries are the biggest problem with sulfur dioxide. China and the United States we see on here, also India, probably Russia, and several others. You can also see, that the developing nations either have a minimal impact or just, they do have a minimal impact clearly, but they also may be already instituting policies or new infrastructure that prevents the emission of CO2. Another trend is that even industrial countries, you can see in Germany, are decreasing their CO2 emissions even though they aren't a significant contributor to the general problem. A solution to this is, or some solutions I should say, are better utilization of oil, natural gas, and lower sulfur coals. Obviously, you still have problems with emitting other gases like CO2, but if we're strictly talking about the sulfur dioxide problem, that would have a great effect. Flue gas desulfurization, which is what Dee, I think it was talking about earlier. It takes sulfur out of the gases as they leave smokestacks, but as she also said, it's a very expensive process. That makes companies or factories slightly more inefficient. There are also systems for industrial boilers, industrial plant exhaust, and metal smelting operations. These are more advanced ones, and these two at the bottom in particular were built